Assalamu alaikum wa rahmatullahi wa barakatuh. Bismillahir Rahmanir Rahim. Welcome to today's physics class. Today we are discussing on the chapter 7, waves and sound. Today is the second class on the chapter. In the previous first class, we have discussed about the concept of simple harmonic motion. At first, we have provided an simple definition, then we have provided an advanced definition. As an example of simple harmonic motion, we can say the example of simple pendulum or mass spring oscillator. We have demonstrated the Hooke's law, and we have also understood how Hooke's law works to explain the motion of simple harmonic. And the formula was F equal minus kx. From this mathematical formula, we provide an advanced definition of simple harmonic motion, that it is a kind of motion where periodic motion where the restoring force acting on the object is opposite and directly proportional to the amount of displacement from the equilibrium position. We have also discussed about the dependence of time period in a pendulum and also in an oscillator. We know that in case of pendulum, the time period increases with increased amount of pendulum length and decreased amount of gravitational acceleration. And in case of oscillator, the time period increases with increased amount of mass loaded at the bottom of the spring, and the time period also increases with decreased amount of spring stiffness or spring constant K. Today we will inshallah learn how to solve some mathematical problems on simple pendulum and mass spring oscillator, and then we'll provide the definitions of different terms regarding simple harmonic motion, like what is called time period, what is frequency, what is amplitude, and what is phase, etc. At first, in your book, you have a mathematical problem in the page number 190, that is, hang a stone of mass 10 gram from a string of 1 meter long. What is its time period? So you have a simple pendulum, and the stone here acts like the bob of the simple pendulum that has a mass of 10 gram. The length of the string is 1 meter long. What will be the time period of the simple pendulum? Here we see in case of the time period of a simple pendulum, it doesn't depend on mass, so we only need to put the value of length of the string and the acceleration due to gravity g. So when we calculate the time period t, we put the values and we get the time approximately 2 seconds. So when we put the values t equal 2 pi root over L by g, so instead of L there is 1 meter and instead of g there is 9.8 ms inverse 2, we get approximately 2.007 seconds or 2 seconds as the time period. Now we will solve some mathematical problems. What is the spring constant of a spring that produces 15 Newton restoring force for 0.25 meter elongation from its equilibrium? So you have provided with a spring, then 15 Newton restoring force acting on it due to elongation of 0.25 meter. So now we have to determine the spring constant of the spring. So as a solution of it, we know the given information, that is the F equals minus 50 Newton, displacement is 0.25 meter, what is the spring constant K? So when we put the values in the formula F equal minus Kx, we find the value of K as 200 Newtons per meter. As a second example of mathematical problem, the time period of a spring mass oscillator is 0.7 second when a mass of 100 gram is attached with the spring. Find the value of spring constant K. So you have given a spring and you have loaded 100 grams mass at the bottom of it, and it vibrates upward and downward requires a time of 0.7 seconds to complete oscillation. You have to determine the spring constant value k. So we have given the information t equals 0.7 seconds, mass m equals to 0.1 kg. What is the value of k? So when we put the values in the formula, t equals 2 pi root over m by k, we can determine the value of k from here, and as a result of it we find the value of k as 8.05 Newton per meter. Now we have a homework. You have 4 mathematical problems to solve. At first, how long does it take for a children on a swing to complete one swing if the length of the rope is 4 meter? So there are 2 children swinging on a swing, dolnate, and the length of the rope is 4 meter. What will be the required time period? The answer is 4.01 seconds. If you have to solve it. Question number 2 is pendulum with a period of 2 seconds in one location that has a G of 9.8 ms inverse 2. The simple pendulum has moved to a new location where the time period is now 1.99796 seconds. So the acceleration is changed. What is the acceleration due to gravity at the new location? The answer is 9.82 ms inverse 2. So here you have you are provided with the hints. You can use it to solve the problem. Question number 3, find the ratio of the old and new periods. Find the ratio between new versus old periods of a pendulum if the pendulum were transported from Earth to the Moon, where the acceleration is 1.63 ms inverse 2. So you will find the answer. The ratio between the time period of new and old is 2.45:1. As a question number 4, what is the effect of the period of a pendulum if you double its length? What is the effect of the period of a pendulum if you double its length? Number B, what is the effect of the period of a pendulum if you decrease its length by 5%? So as the answer of the question number 4A, the period will increase 1.41 times, and as the answer of 4B, the period will decrease to 97.5% of the old time period. So I hope all of you can solve these 4 mathematical problems. Now we will provide some definitions regarding simple harmonic motion. Here we see the left one is a GF animation of a spring, has a mass loaded at the bottom of it, and that is continuously moving upward and downward. And in your book you are provided with this figure that actually represents the movement of a mass spring oscillator at different times. So in this figure you see that the position of the mass at the figure 0 is at the equilibrium position, and that is now swinging, that is coming downward and then forward and upward. So it comes downward at the position number 1, so and then it again moves upward and go to the upward extreme at the figure number 3, and then it goes again downward at the downward extreme at the figure number 5, and then moves upward to the upward extreme figure number 7, then moves downward at the downward extreme at the figure number 9. So here we see the object repeatedly comes to the point of equilibrium at the figure number 2, 4, 6 and 8. Now we will understand what is called complete oscillation or cycle. What is called one complete oscillation? When a body performing simple harmonic motion reaches to its initial position from the same direction, then it is said that the body has performed a complete oscillation. That means now the object, here we see now the mass is nearly at the equilibrium position, that will move downward and then upward and then to the same point. So it gone downward, then upward, and then again reached to the initial position from the same direction. So by the meantime we said that it has completed a single complete oscillation. So if we observe in case of this figure, in this figure we see that the cycle starts from 0 and ends at 4. So starting from 0 and ending to 4, there is one complete oscillation. But from 0 to 2, that is called half oscillation. Then what is called time period? The time required for one complete oscillation is called the time period t. So the amount of time required to reach from the position 0 to reach from the position 0 to the position 4 is called the time period, that is expressed in seconds. Then what is called frequency? Frequency is the number of complete oscillations per second or every second. Its unit is hertz. That means frequency is the inverse of time period. That means f equals 1 by t. So for example, if the time period of this spring is 2 seconds, then the frequency will be f equals to 1 by time period, that is 1 by 2 seconds equals to 0.5 hertz. Then what is called the amplitude? The maximum displacement of a body performing simple harmonic motion from the position of equilibrium is called the amplitude, that is expressed in meter. That means the highest amount of displacement the object has from the position of equilibrium is called the amplitude. So the amplitude can be positive amplitude or negative amplitude, because it has amplitude on both directions, upward or downward, or rightward to leftward. So the amplitude has a positive value at one direction and has a negative value and on the opposite direction. So the maximum amount of displacement is called the amplitude. So here in the figure we say this A denotes the amplitude of the object. And now we are talking about phase. What is called phase? The overall condition at any moment during the simple harmonic motion of a body is known as phase. The overall condition means the displacement, velocity and acceleration etc. of the body at a particular time. Here we see, as the object has a simple harmonic motion, the object has different values of amplitude, velocity and acceleration at different positions. For example, when the object is now at the point of equilibrium, the object has now amplitude of 0 meter 0, and when the amplitude or displacement is 0, the acceleration is also 0. The acceleration acting on it is also 0, but it has a maximum amount of velocity now. As we know that the force acting on the body of simple harmonic motion is opposite and directly proportional with the displacement. So now the displacement is 0 or amplitude is 0, so the force is also 0, that means acceleration is also 0, but the velocity of this object now is at maximum, and the object travels downward and then upward. But at the top position the object has maximum amount of amplitude. As a result, it has maximum amount of restoring acceleration, but at the top position it has velocity of 0 ms inverse 1. That is why we see that at different particular moment the object has different values of displacement, velocity and acceleration. This overall condition is called the phase of the object at a particular moment or time. So at the end of the class, I hope that you will perform the 4 mathematical problems as your homework. সবাই ভালো থেকো ইনশাআল্লাহ। সুবহানাকাল্লাহুম্মা ওয়া বিহামদিকা আশহাদু আল্লা ইলাহা ইল্লা আনতা আস্তাগফিরুকা ওয়া আতুবু ইলাইক। আসসালামু আলাইকুম ওয়া রাহমাতুল্লাহি ওয়া বারাকাতুহু।